Okay, so we're going to do another example of a rational function right now. Okay, so this one's going to be a little bit more involved. Okay, so we're going to start out with, we'll call it g of x is equal to x minus 1 over x minus 1 x minus 3. Okay, now remember, when you find the domain, you want to start out with it unsimplified and you want to figure out what you need to exclude. You want to make sure that your denominator is never equal to 0. So we're going to start out the same way. Okay, so if we set our denominator equal to 0, what we find is x cannot equal 1. Oh, let me back up. And x cannot equal 3. So these are the numbers I can't equal. So these are the numbers that are excluded. Okay, I just list them both. I could do interval notation if you want. Interval notation would look something like this. It's up to you on whether or not you want to. It's just another way of writing it. Okay, now I want you to take a little bit closer look at your rational function you got going here. Okay, it looks like I have something that I can reduce. Okay, so looks like I have x minus 2, or excuse me, x minus 1 and x minus 1 on both the top and the bottom. So I can totally do that. Now, here's the thing. This function is simplified. It's not its original version. So we have to account for the x minus 1 originally being there. It's still not part of the domain though. But now, instead of a vertical asymptote, it becomes what we call a removable discontinuity or a hole. Okay, that's H-O-L-E. So a hole, or this one sounds fancier, removable discontinuity. Is an excluded value whose factor can be divided out. Okay, we're going to talk about graphing now when we get there. Okay, so our hole happens at x equals 1, and then we have a vertical asymptote happening at x equals 3, just like our first example. Okay, so we do have that vertical asymptote going on. Okay, now let's look for our x and y intercepts and let's see if that helps us graph. So let's do my x-intercept first. Let's see if I have an x-intercept. Now, when you do x and y intercepts, it's perfectly okay to use the most simplified version now. So y-intercept, x-intercept. So let's say, I think this one's going to go the same way. We don't have an x-intercept. Okay, that's because when I multiply it through, I get 0 times x minus 3 equals 1. 0 can't equal 1, so no x-intercept. Okay, y-intercept, we set our x equal to 0, And I have a y-intercept happening at negative 1/3. So my y-intercept is 0, negative 1/3. Okay. Now, I think we're ready to start sketching our graph. Now, we haven't talked about end behavior or having a horizontal asymptote yet, but that'll come from our graph. Okay, so let me get an XY axis going on here. Now, until you get used to this, okay, you might want to try graphing by hand and then possibly converting your graphs on Desmos, okay? So again, we're going to use colors. Okay. All right, so there's my vertical asymptote. Okay, so the next thing I'm going to graph is the hole, okay? So when you graph a hole, what you want to do is you want to use the most simplified form. Okay. And our hole happens at x equals 1. So our hole would happen at negative 1/2. Now, when you graph it, you literally graph a hole in the graph. So we're going to find x equals 1, we're going to find negative 1/2, and we're going to put like a big old hole right there. Okay. The next thing I'm going to graph is our y-intercept. Our y-intercept happened at negative 1/3. It's about right there. Remember, this is a sketch. Okay, now if you want to, you can run a table. I would probably plug in like the value 2, and value 2 would give you a negative 1. So it looks like this half of my graph is going to look like this. Okay. Now, if I plug in the right-hand side of 3, so if I plug in like 4 and 5, you'll find that I get this. And it looks like my graph again has that end behavior of, let's talk about end behavior. So end behavior, I have x approaches negative infinity, y approaches 0, x approaches positive infinity, y approaches 0. So that means I have a horizontal asymptote. At y equals 0. Okay. All right. So again, this one was a little bit more complicated. It had a hole. Okay, we're going to do another one. Okay, again, you're going to have several videos on this lesson. Okay, it takes these take a while to do, especially if you're doing them by hand. Okay, all right.